Okay, we're going to do Heron's formula for the area of a triangle, okay? We're not going to do the quadrilateral because that's going to be too much. So we are going to, hopefully we can follow along with this. There's A, B, and C. These are the sides. We're going to define S as A plus B plus C over 2. In other words, it's halfway around the perimeter of the triangle. I think perimeter is the right word for it. But Heron's formula states, if we take this value for S, that there's the end of the proof. The area is equal to the square root of S times S minus C times S minus A times S minus B. Okay, and that's the that's Heron's formula. And let's go ahead and get started because this is going to be a son of a gun. Now, this is not your homework, I hope. You know, this better not be. If your homework is to prove Heron's formula, don't be watching this because your professor is a subscriber of mine if he's cool, and your professor's cool, so she or he is a subscriber of mine. So don't be using this to do your homework now. You're gonna be in big trouble because they're gonna know. Okay, so and the other thing is my handwriting is too sloppy. You want neater handwriting. Plus you want, well, anyways, you're all honest, ethical people, I know. Okay. The area is equal to AB sine angle AB over 2. And that's just taking base times height over 2, really. The height would be B sine angle AB. And you can see that trigonometrically. This is angle AB. Sine of that times B gets you the height. So AB sine angle AB over 2. Now I multiply that by 4 and I get 2AB sine angle AB. Now, this is what I call the algebra train here, so, and the trig train. So follow along, and if you have any questions, and you can't read something, PM me with the, or you can post it maybe with the time on it, and I'll tell you what it is, okay? So 4AR is equal to 2AB sine angle AB is equal to 2 times the square root of A squared B squared sine squared angle AB. Notice I'm just taking this AB sine angle, putting it under the radical, and having it as squared. And now I'm putting 2 under the radical and making it square root of 4A squared B squared sine squared AB. Now you know that the sine squared of an angle is equal to 1 minus the cosine squared of the angle. So I take sine squared AB and make it 1 minus cosine squared angle AB and multiply that by 4A squared B squared to get you this. Square root of 4A squared B squared minus 4A squared B squared cosine squared AB. And that is equal to the square root of a big long thing here. Notice this is a square minus a square. So it's like x squared minus y squared. I just changed that into x plus y times x minus y form. And when I do that, I get the square root of parentheses 2AB plus 2AB cosine angle AB end parentheses times parentheses 2AB minus 2AB cosine angle AB, okay? And you can confirm that on your own because you're not doing this for homework, you're doing this for fun, right? Okay. Now what I'm doing is, you better be, because you don't want to be cheating on your homework with me. That's just not good. Those of you who are my regular subscribers know that's a laughable proposition. Okay, what I'm doing now is I'm taking this and I'm going to add 0 to it. So I don't change anything. Pardon me, I'm taking this and each of these parentheses, this one, and add 0 to both. But instead of 0, it's going to be a squared minus a squared plus b squared minus b squared to both this and to this. Okay, well, it's just 0. A squared minus a squared plus b squared minus b squared, that's 0. For all obviously, I don't think that we need to exclude anything for that. So adding it here and here gets you the square root of bracket parentheses a squared minus a squared plus b squared minus b squared end parentheses plus 2ab cosine angle ab end bracket times bracket parentheses a squared minus a squared plus b squared minus b squared end parentheses minus 2ab cosine angle ab plus 2ab, and that's all under the radical sign, okay? And that's equal to, we neaten it up to make it the radical of bracket a squared plus 2ab plus b squared minus parentheses a squared minus 2ab cosine angle AB plus b squared, n parentheses, n bracket, times bracket, a squared minus 2ab cosine angle AB plus b squared, minus parentheses b squared minus 2ab, shouldn't that be, yeah, minus 2ab plus a squared, n parentheses, n bracket. I'm going to check that because I believe that is, I'm actually checking a T-shirt. Is that amazing stuff or what? Yes, that is correct. So we are now moving along. And I actually, okay, note the law of cosines, that c squared is equal to a squared minus 2ab. That should be ab. I had to write that in there. So again, c squared is equal to a squared minus 2ab cosine ab plus b squared. In other words, c squared is equal to a squared minus 2ab cosine of this angle plus b squared. Okay, that's the law of cosines. So that gives us a nice, neat substitution of c right here. So we're taking this big, long thing here, and we can substitute c into there, and that gets us equal to, nice and neat, huh? Radical of bracket parentheses a plus b squared minus c squared n bracket times bracket c squared minus parentheses b minus a squared, and that's n bracket, hello, yeah, n bracket. Okay, so please don't cheat off of me, whatever you do. Don't use me for your homework, trust me. You deserve what you get. Okay, is equal to, one me is enough, by the way. I have my own unique style, regular subscribers. You all know that. Okay, is equal to the radical of bracket, since this is we're subtracting squares, this is the x squared minus y squared form. I'm changing it to the x plus y times x minus y. And then I'm doing the same thing here. The x plus, this is the difference of two, not the sum, the difference of two squares. It's the difference of two squares and the difference of two squares. And so again, I just convert this out to the x plus y times x minus y form. And I drop the parentheses because they're not necessary. You just get the square root of parentheses a plus b plus c times parentheses a plus b minus c times parentheses c plus b minus a times parentheses c plus a minus b, and all together, in parentheses, and all together it's under the radical sign. Okay, so that is what 4 times the area equals right here. Now, if I divide by 4 to just get the area, which is what I want, I now have a 16 in the denominator under the radical. Okay, it's dividing by 4, but since it's under the radical, I get a 16. That equates to a plus b plus c over the radical of the square root of the square root of bracket a plus b plus c over 2. I could have used parentheses. N bracket times bracket a plus b minus c over 2. N bracket times bracket c plus b minus a over 2 times bracket c plus a minus b over 2. N bracket, all under the radical sign. Now, notice what our s was defined as here. A plus b plus c over 2. Okay? You notice how this is a plus b over 2, so that's s. This is a plus b minus c over 2, so that would be s minus c. In other words, instead of plus c over 2, we have minus c over 2, so that's exactly an s minus c. Notice how we have a minus a, so instead of c plus b plus a over 2, which is the same as s, we have minus a over 2, which is exactly s minus a. So we now have c plus b minus b over 2, which is exactly s minus b. We've affirmed Heron's formula, that the area of the triangle is equal to the square root of s times s minus c times s minus a times s minus b. So that is Heron's formula in a nutshell. And I really appreciate you watching. We got through it.